second annual meeting of 2091.
Okay, just like yesterday and almost every day, you start with this.
Clubs, prizes, halftime, all the games, autographs, all the kinds of things going on with our basketball program and the Booster Club is meeting. To track this spring, contact Coach Knight. I've already planned an email. She's a couple days ago. We had a free track off.
Okay.
Football practice will start on January 30, 10 days away.
Jacob Doyle.
27th. That's your winter activity. Football tickets be sold next week in the ticket booth by the Commons. Cost the tickets $7. You wait to buy one at the door, it's 10. Make sure you have a picture or your student ID to get into the dance that evening. And if you're bringing someone that's not a Spearfish High School student, that needs to be turned in before 12:30 next Thursday, January 26th. Today is the last day to make any second semester schedule changes. Nothing past today.
He's gone.
Registration for next year's courses will take place next week during Spartan time. Juniors,
Kate,
all
Cadence,
juniors
Rachel,
Spartan time on Monday.
Chase, Connor.
Theater, make sure you bring your computer. You will register
Owen.
for those classes after a brief presentation.
Riley, Levi, Lori.
All 912 students will attend Spartan time on Wednesday. That is the scheduled advisory day. Sophomores, you will go through the registration process in the theater. Freshmen, juniors, and seniors will be taking the Friday survey. After that, those who are freshmen, you'll register on Friday of next week during Spartan time. Make sure each time you bring your computer. I congratulate Mrs. Walters. Mrs. Walters will represent Spearfish High School as our high school teacher of the year. She will now be up to the district teacher of the year, which we announced at the Foundation 3 Cheers event on February 16th. Congratulations, Mrs. Walters. All please stand for the pledge. To the flag. All have a great day and a great weekend.
Just like yesterday, say it again. This is you, not you and your neighbor. Getting this right by working together after having done it in class, that doesn't give you a formative assessment of your knowledge. This is your gut check, not you and your buddy's gut check. This is how you determine if you know it or not, or if you need more practice. Okay, you start most days with one of these. C-level, middle of the road problem. This particular example could have been taken out of an Algebra 1 textbook. We should be able to do this. If you make a little goof, 4 out of 5, okay. You make bigger goofs, 3 out of 5, 2 out of 5, that means you need more practice and you have to ask more questions. Okay? Don't BS your way through it because you're only hurting yourself. This is how you evaluate your understanding. Homework is how you practice. This is how you know.
Do you want coordinates for like the axis of symmetry and stuff?
Well, you have to name the axis of symmetry.
I'm just
Equation. Equation's vertical line, x equals stuff. Because I happen to have an extra 15 minutes this morning, and some people are picky, restock. Baby bear let me get out of the house in a decent amount of time this morning. Pavlov's dog's drooling at the sound of the dinner bell. My crack has arrived, my crack has arrived, my crack has arrived. There's a couple of my seniors who like those. Bagos. Notice this doesn't say how to graph it. It just says graph it and label that stuff. And that's how it's going to be from here on out. Because this is material from previous classes, I'm going to cover the different ways to do things. But after that, you do it how you do it. Okay? Just like ACT. I don't care how you do it after that. I swear, Lori, right now you are the epitome of the Fry shut up and take my money meme. Does anyone need more time? Should be about in that 5-10 minute ballpark. I always tell kids, come in, get it done, keep your foot on the gas. Then chill, talk to your neighbor. Oh my God, did you see so-and-so's story? Blah, blah, blah. Whoa. Oh, yeah. Well, it's a line. Lines have equations. That's the equation of line. All right. So we should have not these here. Okay. Wake up, Frank. Thank you. Okay. I'm going to do everything up here manually because I have space to write it. I'll do my Negative b over 2a is my axis of symmetry. In that case, I have negative thing to thing, plug in. B is negative 12, a is negative 4, negative, negative, negative makes negative. 12 over 8 makes 3 halves, or 1.5. I will take 1.5 because it is a terminating decimal. Say that was, instead of 3 halves, say that was 2/3. If you put 0.66, if you put 0.6 with a line, if you put 0.667, no, because you have lost part of your answer. Okay, 1.5 is acceptable here because it's a terminating decimal and you have given me the entire value. All right, that is precision and something that we should have been really focused on in Algebra 2 leading up towards our upper level math classes. Once I have that, I plug it in. If I want to find, because axis of symmetry is at negative 3 halves, x equals negative 3 halves. Remember, for today, if you only put negative 3 halves or if you only put negative 1.5, fine. When it comes time for your quizzes, tests, final, no, because x equals negative 3 halves is the equation of that axis of symmetry. So I have to state the equation. It's a line, lines have equations, write it. I plug in negative 3 halves, getting 9/4 by negative 4 is just negative 9. Negative 3 halves by thing, cancel, 18. 9 plus 18, 27 minus, ew, is that at 24? Or did I just miss a negative? 9/4, fourths cancel, negative, oh, negative 9, okay. Negative 9. 18 is 9 minus 3, okay. Yep, missed my negative back here. Good thing I didn't write it down. Would have been a 6. So at negative 3 halves 6, before I go putting that as my vertex on here, I'm eyeballing this. I know that I'm probably not going to be able to fit 5 points on this graph because it's going to go from the vertex over 1 down 4, over 2 down 16. That's probably not fitting on my graph. Probably not. So if you change your scale, what would be the easiest scale to go by? I would do 4s because then I can do my normal perfect square steps because every box is equivalent to 4. Now, in this case, because my vertex is at 4 or negative 3 halves 6, there's just enough room for 5 points on here, on my graph. Where are you doing your graph? Please tell me you're using graph paper. I've seen some of your handwriting. Okay? You got to make sure that that graph is legit. Otherwise, if you're just kind of BSing it and it's not neat enough to actually distinguish these are at those points. So I have the capability of writing negative 3 halves 6, 1, 2, 3, 4, 5, 6. Happy parabola or sad parabola? Who's sad? I got a negative on there. And since it's so negative, that means we're going to head downtown for the rest of our points. Those points are going to be at, from the vertex, if I go over 1 and down 4, I'm just halfway through the box. 1, 2, 3, 4. So that should be at negative 1/2, 2. And then mirror across, 1 right, 1 left. If I go over 2, I go down 16, which in this case is exactly var. So 1, 2. I barely had enough room for 5 points on my graph. If you went by a scale, you probably could have fit more. Some kids will just, I never want to go by a scale. I'm always going to just go by one, and if it takes me a whole page to do the graph, it's your fault. Okay, you do you. Even as narrow as this is, try to keep it curvy. And make sure that we're labeling everything on here. Graph the quadratic, find and label the vertex, check. Axis symmetry, check. Y-intercept, ruh-roh. How do I know where the y-intercept is? I heard 0. 0 in for x, right? It hits the y-axis when there's a 0 in for x, because all those coordinates are 0 comma something. So if I just shove a 0 in there, -3. So my points weren't exactly perfect because I wobbled, but you get the idea. You should have a y-intercept at 0, -3. Use appropriate scale if necessary. So the things we're looking for are, did you get the correct axis symmetry? Did you get the correct vertex, meaning you plugged it in to find the 6? Did you state the y-intercept? Do you have the correct vertical stretch for it? And then I'll leave one floating back in here for, I swear I did all of that, but I missed a negative at the very first part. Because sometimes that happens. Okay? Remember, I said this, and I'm going to just keep saying it all semester long. You know, those of you just came out of Algebra 2, you know this. All the way up until the last week of class, I'm still saying the domino effect should not ruin your grade. If all the way back here you just legit missed a negative in front of the -12 because you forgot parentheses or something, doesn't that turn this into a +3/2? Doesn't that domino effect into this? Now you have a different vertex. But did you find the other part of your coordinate correctly? Did you still graph it with a vertical stretch of 4 headed downward? If you did all of that stuff, this is where your problem was, 1 off. Okay? So, we cool, it's still something out of 5 every day. You mark what it is, circle it, highlight it, something that I can see. Because remember, you are turning this in, and I'm just recording your scores. Now, when I start seeing a student have 4 out of 5, 5 out of 5 consistently all the time, but their quizzes are consistently running like 70%, now I'm going to start paying more attention to yours and seeing if you're being truthful or not. I would rather that you were just honest with yourself, because this is, remember, this is worth like that much of your grade. Your quizzes are what matter. They're worth 7 times as much over the course of the year. So, please. All right, this can go away. I poke that. We poke this. We poke this. We poke that. All right. I just picked random stuff out of the book. Here's a parabola. You should be able to graph parabola. Some of those parabolas ended up being nasty. Even if the vertex is at a really disgusting spot, can you still, from there, over 1, up 4, over 2, up 16? Even if it's in a nasty spot, you can still do that, right? And that's how we end up with graphs like someone was asking about 37 right before class. Like this vertex was at something gross. It was like 5/8, 130 something over. Like it was gross. But once I'm there, can I still over 1 up thing squared times a, over 2 up thing squared times a? If you can still do that, or what's another way that you can find your vertex and other points? Right? Put Blinky on this side, put Blinky on this side, asks you for a guess, you say, no, tell me the answer. And it just spits out, this is vertex. Just make sure that you have the correct value of the vertex. Don't do it won't give you a fraction answer. You might have to go back to the main screen and say, turn this into fraction. This is why I want to go through the -b/2a thing, because I can use that to get the vertex perfectly. And then after that, I can just plot by points. Nothing wrong with that. Okay? So out of the, what was it, 3 or 4 of them? Did we have any questions? Did we find the solutions? Okay, remember, it's in the Google Drive folder. Since that was in your book, you go into the Wiley folder and you just scroll on down to whatever page this was. This was actually taken from the new books chapter 2. I said chapters 0 through 2 is all kind of jumbled between old curriculum and new. Still the same stuff, it's just the order's mixed up. So I hope you're able to find the solutions. Is there any stuff about it? Maybe we're just freaking out because we got nasty numbers. Don't shake your head at me like that. Get that look when I go home. All right. In that case, remember the holy sheets. You know what? I'll just say, here, let's do this. If you want the holy sheets for the course, like if you want my notes for the course, the Cliff Notes version of them, then just before you leave sometime today, go ahead and put a tally next to it. I'll just print off that many and have them for you on Monday. Okay? Just, if you want that, I'll just print off some copies for everyone who wants it. Okay? But again, all the stuff we were doing yesterday about graphing quadratics, there's the short version. Okay? Your x-intercepts or zeros or solutions are here, your y-intercept, vertex, your general form, your vertex or standard form, how to find your axis symmetry, how to find the vertex in both forms, what A does to it, like, there it is. Okay. So we left off with that. Now, how do we feel? We've gotten a little bit of practice with it. I can do it. I'm not asking if you like it. I'm asking if you can do it. If I gave you that, oh no, it's got fractions in it. Can you do it? A little sketchy. I should probably just do one more to be safe. Or, dude, where's the guidance office? Okay, how we feeling? I see a couple of us are just a little iffy. So let's start off before we start solving these things. Let's try again. This one actually ends up not too bad because dividing by fractions is easy as pie. Flip the second and multiply. Turn your phones off before you come to class. Now remember, I don't care how you graph it. I just care that you graph it. You could dump that into Y1, calculate vertex, plot by points. Done. You could negative b over 2a, function of that, find vertex, use perfect square steps. And b 2a, so 5 over 2a. 2 of that is negative 3 halves, so 5 is times 2/3. 2/3 is 4. Throw in 4. 4 squared 16. 16, negative 12. Negative 12, and 12 is 0 and 6.
Mr. Sullivan, can you tell me I don't remember if this is the best way I should be putting it in my calculator. Because this is the wrong minus sign for the graph function, right? It should be this one.
Yeah.
Because I forgot where it was for a second, and it's just.
Yep, there are different operations in the calculator.
Okay.
Yeah.
I wonder why.
Times a negative versus add the opposite. Because one's an algebraic structure. There is no such thing as as divide. There is no such thing as subtract. They're figments of your imagination. So that's negative b2 negatives, cancel. 2 of those, 3 halves. 3 has 2, 4, 4, 16, 16, negative 12, 4, 24, 12, 18, 4, 18? Yeah.
So if I put 0 in for x, I get the y-intercept, shouldn't it?
0, 0, 6.
6. But
Yeah.
then if I go over 2 and if I go 4 and I square that, then I go down to 16.
12.
Let's see what my just yeah, but then if I go down 12, it's still not at 6, the y-intercept. I'm going to type it. Okay.
Are you doing a scale here?
Oh, yeah. So that I wouldn't cut down my face. Okay.
And that's literally finding the vertex on this and then getting the points, even by perfect square steps, isn't the tough part of this one. It's matching a fraction compression to an increased scale.
Thank you.
I had that kid for an entire year straight. It took me until this morning to realize that you're related to Ben.
Get better. You can't go.
As did I.
Yeah,
Yep.
me as well.
Yeah. Yeah.
How did I
Yeah.
get this? Something's wrong with my
No.
pen. My pen did it. It wasn't me. I did it.
Because right here, you just dropped your negative entirely.
Negatives don't matter.
Yes,
They do
they
matter.
Wish.
How I forgot. And because I didn't. Oh my gosh.
Well,
Yeah, it is boring.
That's what I calculated.
I don't know why I thought it was.
least getting the correct vertex. If you can get the vertex and then plot by points, you're fine. The toughest part of this is going to be, I don't have enough room to go up to 18, so I need a scale. But then I'm going to have a scale that's going times 2, but all my points are going to be a compression of 3/4. The boxes are going by 2s, but all of my my perfect squares are going to get times by 3/4. So now I'm going to have to remember, oh wait, I go over 1 down 3/4, but down 3/4 in a box that's worth 2 is actually down 3/8. 3/8 of a box. So here's what I would do instead. Since I have a 3/4 compression, why don't I pick perfect squares that are divisible by 4? Because then every one of the points that I make is going to be an integer value. 3/4 of something divisible by 4 is an integer. Big brain. Over 4 up 18, like so. Oh, also, if you're going to use a scale, write it on there. Don't just assume that people know what you're talking about. Half of the miscommunications that human beings have is we assume the other people are working with the same knowledge and mental framework as we are. Most of my difficulties with our administration are they're neurotypical and I'm not. Okay? Stop assuming a meaning. Just listen to what I'm saying. Okay? If I go over 1, I would go down 3/4. Well, 3/4 is 3/4 of half a box. Ew. But if I go over 2 down 4, 4 times 3/4 is what? 3/4 of 4. 3. I can just go over 2 down 3. Well, instead of going over 3 and down, 9 times 3/4 is 27/4, which is 6 3/4, and now I have to match that to boxes that are worth 2. But I'm going to say, skip that one, go over 4 down, not 16, times 3/4. 3/4 of 16, 12. I'm just going to skip the ones that aren't divisible by 4. I don't worry about this one at all because it's nasty. Instead, I'm going to go over 4 down 12. 2, 4, 6, 8, 10, 12. Instead of going to over 5 down 25 times 3/4 or negative 75/4 or negative, 18 3/4. But I am going to go over 6 down, not 36, times 3/4. 3/4 of 36. Anyone? 27. Over 6 down 27. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 27. Could I also find every one of those points by just plotting points? Like straight out the table on my calculator? That works too. Okay. And now, Ollie, now look at my y-intercept. At 6 where we wanted it. Okay. This is the difference between Algebra 1, Algebra 2, where most of it is just, I do the thing that they told me to. Monkey see, monkey do. Write down directions, I do thing. I'm a good student, so I can look like I'm mathing good. And understanding these 3 or 4 different concepts, putting them together and taking the bits and pieces that you want or are most efficient for the way that you want to complete the problem. Okay. Could I have the exact set of tools needed to hole punch out this one particular pin so that I can fix this toy for my kid? Yes. Could I look around, pull a key out of my pocket and pop the pin by hitting it hard with something nearby? Yeah, it works. You do what works for you. Could you have found these integer values, this almost, it's halfway through the box, it's integer value. Could you have found those by just looking in the table? You'd be fine. There's nothing wrong with dumping that in your calculator, calculate vertex, plot the points by table. There's nothing wrong with that. We want to be able to do all of the above because the more tools you have, the more successful you are when you're in an unfamiliar situation. So, if we need practice graphing, again, this is year 3, course 3 or 4, depending whether you did parabolas and geometry. 3rd or 4th course that you've done parabolas. By this point, if you need more practice, that's on you. Come on down, I'll happily work with you. Go Khan Academy. Google, I don't know, just graph parabola worksheet, algebra 2. Make sure it's algebra 2, not algebra 1, because algebra 1 will have really nice points. Algebra 2 might have nasty stuff. Just get some extra practice. You're more than welcome. Just take a picture of it, send it to me, and say, hey, did I do it? Okay. Anyone who's willing to put in the time, and I've got a couple in here who actually asked questions in algebra 2, they'll tell you, I'll answer you. I might answer you at 5:30 in the morning, but I'll answer you. Okay? On to the next page. By factoring. Remember, there's an entire decision tree to factoring quadratics. Literally, if you go to the holy sheet, a decision tree for solving by factoring. Step 1, everyone to one side of the bus. Actually, that's like step 0. Step 1, can I take out a GCF? If you have a greatest common factor, get it out of there, make life easier. Step 2, are A and C perfect squares? Because you might have a perfect square binomial or trinomial on your hands. If you do have perfect squares, it's probably going to be 95% of the time, it's going to be one of those 2 special forms, either difference of squares or a binomial squared. Okay? Or, if it's not, now I ask, does A equal 1? If A does equal 1, it's just factors of C that add up to B. If A does not equal 1, you got to go through your full AC method. Maybe you call it the box method. Maybe you call it factoring by grouping. Whatever it is, it's got steps. Steps are written out for us. Okay? Again, this would be the 4th course that you've been doing this in. I look at this one and say, is everyone on one side of the bus? Yes. Are A and C perfect squares? Nope. 1 is, but 12 isn't. Does A equal 1? Yes. Yeah. So that means I'm just looking for what times what makes 12, but add up to make -8. At that point, I hope you know your multiplication facts. If not, you might have to guess and check a little bit on a calculator or bust out an old school multiplication chart. Nothing wrong with that. Sometimes we just brain fart on it. -6, -2. Why does it have to be negatives? 6 times 2 makes 12. Exactly. Okay, now someone always asks, invariably we will get the x minus 6 times x minus 2 is 0, and someone will ask, what if I did it the other way? Why? And multiplication is commutative. 5 times 2 is 2 times 5. Commutative property of multiplication says it doesn't matter which way I have these. Now, that would really suck to get there and then just quit. Hint, hint, your first quiz. That would really suck to say solve by factoring and then just factor it and walk away. I ain't done yet. The idea behind factoring is I just said thing times thing makes 0. Well, if A times B makes 0, what's got to be true? One of them got to be 0. So you set both equal to 0. X minus 6 is 0, add 6. X minus 2 is 0, add 2. I get two different answers. I get two different answers because this particular graph hit the x-axis in two locations. It hits at 2 and 6, like this. Okay, two solutions, two x-intercepts. I find x-intercepts by making y 0. So that's why they're also solutions. Solutions are roots, are x-intercepts, are answers. Okay? So we should be able to do more and more of those by mental math. What if A does not equal 1? Okay. Now, everyone here came out of different algebra 2s. In the last year and a half, we've had 4 different teachers doing algebra 2. Algebra 2 usually gets kind of split up amongst everyone. So I don't know how you were taught it, how they said it. Some teachers will go super old school and they'll say, all right, you're going to have something, 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 and then you just have to guess and check all the factors of 2 and all the factors of 4 against each other, guess and check until you run into the magic pair. Some teachers will go old school like that. Personally, I never learned that there was another method than this until my 4th year of teaching. I just always mental mathed it. And then I just started doing the abstract algebra for it, and I created a method and was like, dude, this works every time. No way. And I've proven it works. Went to another math teacher, said, hey, look at this. They said, yeah, that's just how you're supposed to teach it. Oh, well, score 1 for rural Podunk, North Dakota, Algebra 1. North Dakota is just like South Dakota light. It's bad. Or box method. Anyone do box method? Where you're trying to find what factors will make 2c squared, what factors will make 4, but their diagonal will add up to 9. It's just a visualization of the guess and check method. I don't know if anyone showed you that. Personally, I like showing the full AC method. It's called factoring by grouping. Step 1 is you're going to GCF. If you can. I don't see a GCF, so I won't. Step 2 is you take A times C, and what factors of that add up to B? So I'll take 2 times 4, and I get 8. So I'm looking for what times what makes 8, but adds up to 9. 8 and 1. Now it's dangerous here. You can't just say C plus 1, C plus 8. That's not the answer. It allows you to now split B. And this is why we call it factoring by grouping. Is right now I only have 3 terms. Also, the order doesn't matter here. It'll work out the same no matter what. So maybe I say 8 C's plus 1 C's. This other stuff is still there. Okay, I just needed to split that middle term. Because now I have enough terms to group things together. Switch them to x's, that's fine. Think of it like, you ever been in that like group of friends where it's 3 people, it's you and 2 other people, and the other 2 people start dating. And now it's just friggin' awkward, right? Everywhere you go, they're all hugged up on each other and you're just sitting there like, screw it, I'll just mess around on my phone. Okay? But if there was another person there for you to commiserate with and say, man, these guys suck, then it might be more enjoyable. I need to split B because step 4 is to factor each half. Because now I have enough for groups. This is why it's called factoring by grouping. I group these 2 together, I group those 2 together and say, what do they have in common? These 2 look at each other and they say, we got a 2C in common, leaving C plus 4. These 2 look at each other and say, well, we don't really have anything in common, but we can agree that those guys suck. So we at least got a 1 in common. You put a 1 as a placeholder. This right now is a bigger, uglier version of, do not write this part. What if I said 2CD plus D? Couldn't you take a D out like that as a GCF? It's the same thing, it's just they got this in common instead of a D. You factor out the common binomial. They both have a C plus 4 in common, so if I take that C plus 4 out, bye-bye, bye-bye, I have a 2C plus 1 left over. And then you set them equal to 0 and solve. C plus 4 equal to 0, I'll subtract 4. 2C plus 1 equal to 0, I'll subtract 1, divide by 2. And you probably got pretty good at doing those by mental math, just 2-step in Algebra 2. Those steps. That is the AC method. You might have heard it called AC method. You might have heard it called factoring by grouping. Some of them will, I've seen one textbook call it algorithmic factoring, because algorithm just means it's a step or a process. So, that look familiar to anyone? Not from my room?
That looks familiar, but like I don't get what you did with the last step. I like was looking down at my notes and I just missed it.
Okay, just like if I had 2cx plus 1x, I could take an x, that's the greatest common factor, out.
Yeah.
It's 2c this, 1 this. They have that in common. So just like I can take an x out, leaving a 2c plus 1, I can take an entire c plus 4 out, leaving a 2c plus 1. That's factoring by grouping, where I'm able to take an entire binomial out. And what we're going to do as we get into chapter 1 and 2 is you're going to see more of this with polynomials, where I might take an entire quadratic out. I might take a 3-term quadratic out, leaving a binomial. I might take a binomial out, leaving a 3-4-term polynomial, because now we're into higher order factoring. It's either that or we got to guess and check. Now the guess and check, if you do that method, if you know the numbers, if your numeracy is good enough, shouldn't actually be too bad. Because in this case, the only way I'm making 2c squared is by 2c and c, right? It's a prime number. If it's a prime number, then I just got to mental math my way through the factors of 4. Well, if I put a 2 here, 2 by 2 is 4, 2 by 1 is 2. Nope, that doesn't make 9, so we'll try 4. 8 plus 1 is 9. Cool, I win. You can mental math your way through some of these. If you can, great, good on you. Go ahead and do it. If not, you might have to full AC method your way through it. So I'll leave that there and say 7, 8, and 10. 7 and 8 are the easy peasy ones. A equals 1. 10 is another AC method. Let's see what you got.
I was just confused about the answer.
Oh, I set them equal to 0.
Okay, but like the caret, was it -4?
And.
Okay.
When we went through sets the other day, said that's the and of the math world.
Okay.
Yeah, sometimes I'll put the comma, sometimes I'll put the ampersand thing, sometimes I'll put the caret. I don't know why. I just switch between them. And again, on that holy sheet, that whole decision tree, it's right there. -6, -3, so. -8, -2. 3, 1, 3, 4, 2, 3, -6, 2, 3, 4, 4, 3, 3/4, and 2, 1 1/2, -1/2. Right? -1/2 squared is 1/4, 1/4 is 2. 2 minus 1 is 1, 1 is 3. Oh, negative, yeah, okay. Mental math before lunch. Highly don't recommend it.
Sitting on that chair. We're taking a test. This is I'm kind of confused on how you had us write down that one step A times C. The question mark over that must be.
What factors of A times C add up to B? We getting there? I hope. Okay. Now that y'all out of Algebra 2, if you're using a TI-84, depends on what is factory loaded on there or not, hit apps. Depending on the model, you might just have finance and that's it. But some of you are going to be able to scroll on down to Polynomial Simulator 2. Purple. Kitty corner from Alpha. If you go down to Polynomial Simulator number 2 and then Polynomial Solver, you can literally just type in whatever the polynomial is, including quadratics, and hit enter, and it'll solve it for you. Yeah. Yeah. Now that you're past Algebra 2, we can show you that.
I don't know if I have.
Polynomial Simulator 2. Ba-doop boop.
I hit that and then I hit something else and I have no idea how to get out of that.
Next.
Submit
Graph.
next.
So you would do a polynomial root finder or simultaneous equation solver. That's for like 3, 4, 5 variable systems. Okay, polynomial simulator. Bump. Yours is a quadratic, so order 2. You want real answers or your imaginary answers. You can type it in however you want. You hit next. You type in whatever it is and you hit solve and it tells you the answer. I could have waited until after the next test to show you. Well, you got apps on there. It's just whether they're preloaded or not. Apps. Yeah, go down. Should be option 9. Oh, no, that was your probability. This is where you can flick the spinner or roll dice for you. Right? Said you can put all kinds of stuff on there. Press the any key. Where's the any key? Okay. Quit. Yes. Apps. Where's yours? Probability simulator, Connix. Nora.
What?
Algebra 1, Chapter 5.
What? This is old. I bought this off of someone in our Walgreens for $20. $20? Yeah, $20.
Linear systems.
They downloaded a bunch of stuff onto it, or?
Someone put all their notes for Chapter 5 in here.
I need it too.
I said you can program all kinds of stuff in here. I was playing Monopoly and Wheel of Fortune 20 years ago.
I don't know how to get down to solve.
You press the button right below it.
Oh. Okay.
Ta-da! Man, no. It depends whether it's preloaded on there or not.
So once I get here, what do I do?
Polynomial root finder. Order 2 because it's quadratic. You can make it give you complex numbers, imaginary answers if you want. Hit next. You type in what A, B, and C are, and you hit solve.
Okay.
If it's on there. Some of these calculators don't have it. It's just finance and done. Now, y'all notice there's a little plug-in in the calculator. You can plug this into your computer and you can download stuff. You don't have to code it by hand like we did 20, 25 years ago. You can just say, hey, go download Wheel of Fortune. Don't do that. Well, you can do that, just don't do it in here. You can program pretty much anything on there. These are very simple, basic computers. This TI-84 is essentially a handheld version of the old like Apple Mac II with all of the 5.5-inch floppy disks on hand.
So this one?
Yeah.
And then so
Next, so you hit the button that corresponds with it.
This one?
Yeah. You type in, so, oh, you went into systems. You went into simultaneous equations. So you would go second quit. There you go, polynomial root solver.
Next.
You just type in what A, B, and C are, and then you hit solve.
Oh.
Okay,
How do I get out of this menu?
second quit. So, now that I have shown you the forbidden magic, let's come back here and are we able to actually factor these though? I am not joking that I'm showing you this as a way to check answers. If you can't factor a quadratic, you are beyond screwed for this class. Okay? This is something that you should have done for 3 classes straight prior to this. If you can't do this, like if this is genuinely, I don't even understand what's going on. A, how did you get through Algebra 2? B, how did you get through Algebra 2 with a C or better? And C, today's the last day. Okay? And I'm not saying that to be a jerk. I'm saying that because I don't want anyone set up for failure. I don't want anyone coming into a room trying to do something that they are literally not prepared to do. I would not want to just say, you know what, I'm going to sign up for a 5K. Y'all, I haven't run in years. I would have a heart attack. My knees can't handle it anymore. Okay? Don't set yourself up for failure. If you can't factor, then we're hosed. I'm assuming 7 and 8 are fine. 10. A times C is negative 24. I'm looking for what factors of negative 24 add up to negative 2. 6 and 4? There we go. So we'll call that 8k squared minus 6k plus 4k minus 3 is 0. I cut it in half. I ask, what do these two have in common? 2k. Leaving, back up. Leaving 4k minus 3. These got nothing in common. So I put a 1 as a placeholder, leaving 4k minus 3. And I see that the pair of them, they both have a 4k minus 3 in common. So if they have that in common, it can be taken out like this. If I take it out of there, there's a 2k plus 1 left over. Set both equal to 0 and solve. If I do 4k minus 3 is 0, k is 3/4. If I do 2k plus 1 is 0, k is negative 1/2. And I'm betting most of us just started doing that mental math, probably Algebra 1, Algebra 2. Subtract this, divide by this. Add this, divide by this. So, we got to be able to factor. Just, you have to. Don't rely on the tools. Don't rely on the app I just showed you. Don't rely on your calculators to do all the work for you. Because, as you, maybe, and definitely some of your peers have found out, what happened to all the kids who just photomathed their way through Algebra Half and Algebra 1? They doing so hot? Okay. Do you really want to be in PreCalc relying on the calculator to do everything for you and not understanding what's going on? Okay. Complete the square. In Algebra 1, we teach you complete the square. And then we show you quadratic formula. You're like, I'll do this all day long. And you forget how to complete the square. In Algebra 2, we show you how to complete the square. we include imaginary numbers. And then after that, we show you how to quadratic formula with imaginary numbers. You're like, I'll do this all day long. No. And you stop doing complete the square. You need to know how to complete the square because when we hit conic sections in PreCalc, you complete the square twice per problem as a minimum to even find the equation because it's not in the right form to start graphing. You have to know how to complete the square. So, you know what? I want to spend the rest of our time on this and throwing nasty numbers at you. Let's actually go to the quadratic formula part first. Solve that by quadratic formula. Just go. Tell me that you know how to do that. It's right up there. Top row. Fourth in from the left. Negative b plus minus b squared minus 4ac square root of that all over 2a. The previous pre-calc teacher, like eight years ago? Yeah, 8 years ago, he refused. I actually found these in his closet. He refused to put these up because he thought any form of notes was cheating. You should be able to come into every test and just raw dog it. I did not agree with him on a lot of things. He was a nice enough guy, but we just had very, very, very different philosophies on education. He said if you're not done with anything on a test or whatever by the time is up, too bad. Should have done better.
I got 44.
15 plus 4 is negative 11. I'll take both. After our conversation the other day about complex numbers, I'm going to put mine there. I will take both. See, to me, quadratic formula is actually more complicated because there's more steps. I can complete the square in my head all day long. Quadratic formula? Nah.
Wait, is that the answer?
Yeah. Mm-hmm.
Okay, so if I take that of that, but I added subtract 6.
I read red upside down. You're good.
Okay.
This is positive 20 or positive 16. 16 minus 60 for negative 44. Took out 4. Okay. Oh, wait. How are you getting a 6 out there?
Because it's like you can take 36. 6 times 5.
Oh, no. Factors of negative 44.
Oh.
So we break this into negative 1 by 4 by 11. Its factors can come out of radical town. So square root of 4 is 2. I 11 left in. There you go. No, I get that though. It's what perfect square goes into this, not just what perfect square is below this.
For some reason I can't remember.
Order of operations, sir. What is negative 4 of the quantity squared?
Negative 16? No, 16.
16.
Because it's canceled.
Attaboy. Okay. 4 by 1 by 5.
15.
No. Oh, that's a 15. 4 by 1 by 15.
60.
Okay, so
Yeah, 60.
16 minus 60.
Negative 44.
Correct. So you are now at a positive 4 plus minus square root of negative 44 all over 2. We turn this into negative 1 times 4 times 11 because I can take perfect squares as factors out of radical town.
Okay. So then it'd be 4 plus or minus, and then we take out the 4 on the 1, so it's 2.
2i. Remember, squared negative 1. Root of 11. All over 2.
That's just gonna
Separate your real friends from your imaginary friends. And reduce, please. All right. When you do this, please, 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 use parentheses. Plug in A, B, and C. Negative 4, 1, 15, 1. Getting 4 plus minus square root of 16 minus 60 is negative 44. Negative 44 breaks down into negative 1 by 4 by 11. You're looking for factors to come out of radical town. Square root of 4 is 2. Square root of negative 1 is I. And please, oh please, do not, and I always see a kid do this, say 2 plus 2i root of 11. Every time you do that, you kill a mathematical puppy. You should feel terrible. Don't do it. Okay? Math is communist. What you do for one, you do for all. If you take a 2 out of here and here and here, now we're okay. Okay? That's why it's 2 plus or minus root of 11i. Use parentheses. Order of operations says take care of what's inside the radical first. Do not divide until the very, 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 very end. Separate your real friends from your imaginary friends. Also separate your real friend or your rational friends from your irrational friends. That's how we end up with compound answers. Okay? I'm going to assume because quadratic formula is the thing that you relied on for the last 3 years, this is what you know. If you're rusty on it, get some practice. I'm not going to make us do any of these unless you want to. Complete the square is where we need our practice. Okay? I like putting down steps, so here we go. Step 1 and 2 are completely interchangeable. It doesn't matter which order I do them in. Okay? I can, step 1, variables left, constants right. It's like a middle school dance. Boys over here, girls over there. Envy's looking at everyone afraid. Okay? If I'm going to complete this square into a perfect square trinomial, that guy's in the way. So I say, get out of my spot. And I shove him over to the other side. Variables left, constants right. Step 2. Eliminate the Canadians. Divide by A. Okay. Divide by A, meaning if there is an A value that is not 1, you want to divide everything by that or else it's going to ruin the next few steps. I make Canadian jokes because my mother-in-law was Canadian and it made her furious. But that's okay, she's dead now. She's a horrible person. I don't need to divide by a here because a is 1. So we good. Okay? Even my wife hates her. Okay? So, do you remember what the magic number is to complete the square?
No.
No. Well, yeah, that's the number, but how do I get it?
You write it.
B over 2 squared. Yes. I'm going to add the quantity b over 2 squared to both sides. That's the magic thing that is going to complete this square. In Algebra 1 and 2, you should have seen like a visual representation of this, where there was literally a square missing from the corner of a figure if you try to create a square out of algebra tiles. But I know that most people don't algebra tile, so don't worry about it. Half of this is negative 2. Negative 2 squared is 4. Which means now I have x squared minus 4x plus 4, which is a perfect square trinomial. What factors of 4 add up to negative 4? Negative 2 twice. So it's that thing squared. That's what makes it a perfect square trinomial. I am now able to write that as not a 3. I am able to write this now as x plus b over 2, the quantity squared, is some number. Every perfect square trinomial breaks down to this. B is negative 4, half of that is negative 2. I can write this as x minus 2 squared is 3. And then, if I had x squared equals 3, how would you solve that? Square root. I can still do it here, even though there's more stuff inside the parentheses, I still solve by square roots. If I square root this and I square root this, square root of a squared is just thing, my radicand. And yes, because I put the radical there. Like if I asked you, what is the square root of 9? 3. Or negative 3. Because it's both, if the radical is already there, I go with the positive one. It's called the principal root. But if I'm putting the radical there, I don't know which they meant, so I have to put both, plus or minus root of 3. Then I add 2 over, and I leave it like that. This is a compound number. 2 plus root of 3 is about 4.7. 2 minus root of 3 is about 0.3. We're going to leave them like that. Compound numbers are the most simplified they can be. If you give me the decimal answer of this, I will count it wrong. Hint, hint, multiple choice finals. Never choose equals decimal. I know a couple of you got by that. Okay? We talked about that. We've talked about that so many times. That is not the right answer. You are losing part of your solution. You have to make it a compound number because this is the simplest way that it can be written and contain the entire solution. Now, if I walk into the local home center and I say that I need 2 plus square root of 3 feet of mesh for my to replace the screen on my window, they're going to look at me, go cross-eyed a little bit, and grunt. In that case, yes, I would say approximately 3.7 feet. Okay? So this is the correct answer. If you want to put a decimal approximation next to it, you can, but this is what we want. It's called a compound number. You separate your rational friends from your irrational friends. Okay, I'm gonna do one more where what happens when, oh, those all come out nice though. What's wrong with that, they say. All right, let's do 16. It comes out decently. You're going to learn real quick in here not to work ahead because sometimes I go change values in them. It doesn't do the kind of practice that I want you to do, so I'll change values. So don't work ahead. I might go monkeying with things. Follow the steps. Variables left, constants right. Divide everything by A. Everything by A. Don't forget about that 1 on the other side. Add B over 2 squared to both sides. Write it as a perfect square binomial. Half of B is what? It's in the B spot. Remember, ax squared plus bx plus c.
But when would be half of that?
Because you changed it. You're now working with this. Yep.
That's why I was confused then.
Yep. It's always off of what the current thing is, not the original.
Okay.
Think of it like frosting a cake. You're not putting frosting on just a layer of batter. You know, it's already cooked up. Yeah.
How do I get x plus b over 2? Like, what makes it that?
Because this number, being a perfect square trinomial, is always going to be half of your middle term, and it's going to be the square root of this term.
Okay.
That's what makes it perfect. So I'm able to write it like this every time.
Okay. But then what would it be for that?
This is your B term. What's half of that?
-1?
So C minus 1.
You just do it squared. Oh.
Yeah.
And it's that? Okay. Wait, how do you use my box? What is my squared?
Square root of a fraction is a fraction of separate square roots.
So you put the plus or minus on the top of the fraction?
Just like a negative on a fraction can go with numerator, denominator, or out front.
So it doesn't matter.
Yep. Okay. Step 1, variables left, constants right. It's already set up. Step 2, eliminate the Canadians, divide everything by 4. Careful, that's now 1/4 over there. When I add b over 2 squared to both sides, and this is something that we need to clarify, it's right here. This is of the form ax squared plus bx plus c, or equals c in this case. This is your b term, not the original, extra crispy. Okay. Half of -2 is -1. -1 squared is 1. Don't forget to do common denominators if you need to. This is now what factors of 1 add up to 2. It's -1 2 times. That's why it's a perfect square trinomial. This number, because it's so perfect, will always be half of the middle term and the square root of the constant. That's what makes it perfect. Like, it's symmetrical. It's golden ratio. Okay. This, when I square root, just cancels out. I end up with c minus 1 to the radicand. When I square root a fraction, don't you dare leave it as just plus or minus square root of 5/4. That's a square root of 5 over square root of 4, which can be simplified as to square root of 5 over 2. Add 1 over. Okay? I said I don't like having the other ones because they were easy peasy. Let's make it nasty. Now, all three of these numbers are relatively prime, meaning they share no factors. That changes things. Let's see what you got. And when you finish that one, that's where we're done. -5/3, 8/3, half that, 4/3, 4/3, 16/9, 16/9, -5/3. 3, 3, -15/9, 15/9, 16/9 is 1/9. It's 1/9. Plus or minus 1/3. 1/3 divided by 3, 4/3. 4/3, 2/3, -2/3, plus or minus 1/3 is -1/3 and no.
Yes. Did you just make it even nicer?
Huh. It comes out as rational numbers. Yeah.
Did you just call me Samantha?
Huh.
I did not.
Oops.
What'd you get?
I got.
It's factorable.
You got 4/3. I got 4/3.
I didn't intend to do that.
What? Because you just put the second outside, so 8/6 times 10 is 8/6, which is 4/3. You don't flip the second. You're supposed to square you over 1. Yeah. What is happening? You can't flip the second. Why
3,
can't you?
1, 5, 1. 3, 1, 5,
And
1,
I divided
-1/3.
Where'd you get 8/6? Because you flipped. So the 2. Yeah, so the 8/6 simplifies.
Negative 1/3 and
Would it be negative 1/3? Negative. Just like really bad.
negative 1/3 and 1.
And then just I just like no. That's it's okay. So then I get 16/9. Oh no.
Right, 3, 5.
That's literally what I had. We're arguing about it.
3, 5, 1, 1.
That's funny.
3, 5, 1, 1, 0, 5, negative 1, negative 5, negative 5. Yeah. Huh. I did not intend to make it that way.
I hate this.
Put it down. Do it for real.
I did. Now I'm just making.
Okay.
Don't listen to
C's answer picks up calculator.
I just
Okay. We'll do a little bit more of this tomorrow. Tomorrow? Monday. We'll just start Monday with 1 or 2 of these to be safe. But I will include these in your assignment.